Hey everyone, in today's video we'll be making the classic laser tripwire detection and we'll be using an Arduino, a 50 milliwatt laser, some wires, a breadboard, and it's even better if you can 3D print some components. So let's get right into this video. So how does a laser detection system work? Well, first up, you gotta have a laser and you gotta have something to detect that laser. In this case, we're gonna be using a 50 milliwatt laser. This is just an analogy. I'm gonna use this to explain. We're gonna have a laser and we're gonna be using a photodiode to detect that laser. So laser shines a beam onto the photodiode. Photodiodes are cool because they generate a voltage when a beam shines on them. So then we've got the laser shining a beam and we measure the voltage that it's shooting out. And in this case, it will be around 2.5 volts. So that will be our threshold voltage. And when we're programming on the Arduino, we basically tell the Arduino whenever the beam goes below a 2.5 volts voltage, when the beam is cut, that's when you send out a signal and you say the beam is tripped. So it's very simple. You got a threshold voltage. Whenever the beam is cut, the voltage drops below that, and so it tells the system the beam is tripped. So it's very simple. Okay, so how does the circuit look? Well, to have a circuit, we got to build one first. So build montage, go. Okay everyone, here's a video of our completed circuit. We've got a hole cut out in this fake book here. As you can see, it's a nice disguise. So we open it up and we've got the Arduino sitting here, kind of blue tacked at the bottom. We got our breadboard, and this right here is our photodiode. So it comes out the other end, as you can see. It's got kind of a clear surface. That is our photodiode. Got everything hooked up here to our circuit. We've got a ground line on this end and a power line on this end. Here is the cable connecting to the Arduino, and I'm going to show you how this works, and I'm going to show you a clear version of the circuit itself. So how does a circuit work? Well, first of all, in the middle of our board, we've got an op amp, or an operational amplifier. What does an op amp do? Well, an op amp amplifies the difference between two inputs. So in this case, we've got number one input, the voltage from our photodiode, which is connected right here. And then our second input is the electrical threshold voltage that we've created with these two 120 ohm resistors. So this will create a voltage, say 2.9 volts. This will create another voltage, say 3.5 volts, and it will amplify the difference between these two voltages. So alongside the op amp, we've got a few other things. We've got the analog 0 pin, which is connected to the op amp. So what the analog 0 pin does, it basically feeds the Arduino the voltage. And as we mentioned before, the op amp amplifies the voltage difference, so it makes it easier for the Arduino to read the voltage. The voltage becomes bigger. We also got the 120 kilo ohm resistor, which is quite a lot, but this large value allows the op amp to become more sensitive. And so that's basically how the circuit works. We've got a ground rail on this side, a power rail on this side. Oh, I messed it up. Power rail on this side, ground rail on this side, connected to ground here, and power rail connected to 5 volts. If you have any questions, please let me know in the comments. So here's our initial rough prototype. As you can see, we've got just a 50 milliwatt laser trying to thumbtack to a piece of board, and then the photodiode kind of receiving this beam. And then we've got this connected up to this circuit, which is connected to the serial monitor on the Arduino interface. As you can see, we're getting around 3.6 volts right now. But then I've slowed this down for you, but the second we trip the beam, it says trip voltage 2.9 volts. Our threshold voltage is around 3.2 volts. And then the second we restore, we lift our hand up, it'll say voltage beam restored. As you can, I've slowed this down for you guys by about half a second with a delay down here. But as you can see, our threshold voltage is around 3.2 volts. yeah, I'll show you the sped up version as well. So here's the sped up version of this prototype. We've got only a 15 millisecond delay now, and as you can see, it's going much faster, and I can show you. So you trip the wire and it instantly shows up. Trip and then beam restored. Trip, beam restored. I'll show you how that looks on here. Trip and then beam restored. All right, guys, with all that out of the way, we can get into the fun part, setting up the lasers. So basically what I've done is I've set up the laser on that side of the room, plugged into the wall. It's a separate laser, a 50 milliwatt laser. Be careful, guys. Don't let it shine into your eyes, and don't use too powerful of a laser. I find that 50 milliwatts is a good way to go. And then we've got our book, our fake book, which will sit on the bookshelf over there. And we can use these 3D printed parts to reflect that mirror across, reflect the laser beam across the room, and eventually shine onto this photodiode, which connects to our computer, which will tell us when the beam is tripped. More on these joints later, but cue the video. This is how it looks at night. All right, everyone, so this is how it looks with the lights off. We've got our laser and the collection point. So when you walk through, you get an alert, and it'll reset afterwards. As you can see, we've got all our voltages here. And the second it goes below the threshold voltage of 3.2 volts, the alarm will be tripped. And if you're wondering how I got that video to play, I basically wrote a quick Python script, which basically reads the Arduino serial monitor. And every time it goes below the threshold voltage, then the Python script will run a video, which in this case is the klaxon or alarm red alert from Star Trek. Every time someone trips the beam, Python script reads the serial monitor and plays the video, alarm cues. All right, thank you everyone for watching this video. We'll see you guys next time. Peace out and bye-bye.